Section 1.4 Functions. What you say becomes what you do. Section we're going to look at functions, and functions play an important role in the entire course. So the first thing we want to look at is what is a function. So the row of a correspondence that related two quantities is called a relation. A relation is a set of ordered pairs. So in the first section 1.1, we learned what a set of ordered pairs was. The set of all first components of each ordered pair is called the domain of the relation. The set of all second components is called the range. What I mean by that is if you have an ordered pair, the x here is considered to be your first component and the y is the second component. Each value in the domain is also known as an input value or an independent variable. Each value in the range is known as the the output, and we say it's a dependent variable, depends on the x. So example 1, determine the domain and the range of the relation. So we have a relation because it's made up of ordered pairs. These are your ordered pairs. So the domain is going to be all the first components. So in this case, we have Jeep, Mazda, Kia, and Honda. So that's your domain. Your range is the second components. In this case, we have 60, 55, 35, and notice that 35 appears again. You just need to write it once. Okay, so letter B, the domain here, the components would be the heights, 5'5", 6'5", and 6'6", and the range is the names, Tomás, Miguel, and Ray. Okay, so that is looking for the domain and range given a relation. So now let's look at the next objective. So here we have a function is a relation in which each possible input leads to exactly one output. We say the output is a function of the input. Another way to look at function is that a function is a relation in which each element of the domain corresponds with one element in the range. There is one and only one output with each input. And last, a function is from set A to set B as a relation that assigns to each element in X exactly one element in Y. Okay, so here we have some examples. So looking at the definition, we can apply that to see which of these are functions. It's kind of hard to see here, but we have a 1, a 2, and a 3. I'm going to write them here so you can see them. And on this side, the numbers are 6, -8, and 6. So here we have 1 is going to 6, 2 is going to -8, and 3 is going to, this is, 6. So what you want to do to figure out if it's a function, ask yourself, is 1 going exactly to one element in the range? And 1 is going exactly to 6, 2 is going exactly to -8, and 3 is going exactly to 6. So we say that this is a function. On the next one here, we have the numbers are 8, 7, 2, and 4. And over here we have 5, 9, 3, and 5. So here 8 is going exactly to 5, 7 goes exactly to 9, 2 goes exactly to 3, and 4 goes exactly to 5. So they're each going to just one item in the range. So that's still a function. Here we have 7, -5, 6, and 8. And on this side, we have the number 30. So here, again, we ask the question, 7 is going exactly to one thing, which is 30. 5 is going to exactly one thing, which is 30. 6 goes to one thing, and 8 goes to one thing. It happens to be the same thing, and that's okay, because each of these is only going to one thing on the range. So this is still going to be a function. And the last one, you have the number 8 here, -5, 8, and so here is 8 going to just one thing on the range? And the answer is no. 8 is going to 3 different numbers in the range. So that makes it not a function. So the important thing is that in the domain, this number should only be assigned to one range. Okay, letter E. So we ask the same thing. Is -2 going to only one thing? Yes. Is -1 going to one thing? The answer is no. -1 goes to 3 and it also goes to 4. So automatically that makes that not a function. Letter F, they give us the information a little bit different than this picture, but you can draw your own picture. So remember, the input is your domain. So we have the number 0, 1, 2, 3, and 4. And then for range, we have -4, -2, 0, 2, and 4. So 0 is going to -4, 1 goes to -2, 2 goes to 0, 3 goes to 2, and 4 goes to 4. They're all going to just one element in the range, so that makes it a function. Let's look at page 18. Determine whether each relation is a function. So again, as I mentioned, they give you a set of ordered pairs. If it helps, you can make yourself a little graph here or a little picture. So the domain is all the first numbers in here. So we have 0, 8, 6, and -3. And then the range is the second numbers, which is 9, 7, 8, and 5. So 0 goes to 9, 8 goes to 7, 6 goes to 8, -3 goes to 5. So you can see that all the domains are going to exactly one item in the range. So we say that this is a function. Okay, number 2. Again, you can draw yourself a picture. Eventually, you won't need the picture, but for now, if you need it, it's fine. So the domain is 4, 5, 7, and then there's another 5. I'm not going to include it twice. And then the range is 0, 10, 8, and 7. So 4 is going to 0, 5 is going to 10, and then 7 goes to 8, and then 5 goes to 7. So notice that 5 is going to 10 and it's going to 7, so it's going to two different items. So we say this is not a function. So a shortcut that you can think about here is, notice in our domain here, the first components were all different and it was a function. Over here, for 5, notice that 5 appears twice. So if a number is repeated, it's not going to be a function. So let's look at this one. We have -5, 6, 3, and -9 different. So that's going to make it a function. Okay, so let's look at example 4. And before we do example, I want to write the following statement. Y is a function of x. In this statement, x is your input, which is your domain, and y is your output, which is the range. Okay, so that statement is going to help us to do example 4. So it says, is price a function of the item? So we want to know which one is a domain. Is it price or is it item? Okay, so if we compare this sentence to y is a function of x, Let me write it over here. So here, notice you have a function of, a function of. Okay. So in this case, you can see that item is your X, and you can see that Y is your price. Okay. So I'm going to make a table here for my domain, and then a table for my range. So in my picture to the right side, I'm saying that item is your domain. So we have a plain donut, we have a jelly donut, and we have a chocolate donut. And then your price is your range. So we have 149 and 199. And 199 is repeated, so we don't have to write it twice. So we can see that the plain donut is 149, the jelly donut is 199, and the chocolate donut is 199. So you can see that each of these items go to just one price. And so we say that this is a function. Okay, number 2 is the item a function of the price. So here we have, for example, in the statement, I could say is y is a function of x. So here we have a function of, a function of. So price is going to be your x. And y is going to be your item. So if you make a table now, your domain is the price, 149, 199, and then your range is the types of donuts. So we see that 149 goes to the plain donut, but 199 is going to two different types of donuts. So that's going to make this not a function. So sometimes you're not going to be given a list of ordered pairs. And so you might be given a graph. Okay. So we use something called the vertical line test to help us determine if something is a function. So basically, what this is saying is use a vertical line test to determine if y is a function of x. So you can draw a vertical line anywhere on the graph, and you want to consider all parts of the graph. And if this vertical line crosses the graph in two different places, like we have here, then that's going to make this not a function. Why? Because, for example, here you have that in -3, the output is 2, or -3, the output is -2. So what we're saying here is this point here is -3 and 2, and this point is -3, -2. So if you were to make a table, you have -3, 2, and -2. 3 is going to two different places, and that's going to cause it not to be a function. So number 2, if I draw a vertical line here, notice it only crosses in one place. So that's going to be a function. And then in the next one, if you draw a line, it crosses in two different places. So that's not a function. And then the last one here, if I draw a vertical line here, notice it only crosses in one place. But you might be wondering, what if you draw the line over here? It's touching this point and this point. So just briefly, we'll discuss it later. If you have a dot that is filled, we say that this is a closed point. And what that means is that the point is included. It's part of the graph. If you have an open point, or that's going to look like this, that means that the point is not included. So in this picture here, even though it's touching this open point, that point is really not part of the graph. And so this is still going to be a function because it's only touching the closed dot. Sometimes you're not going to have a graph, so we're going to have something that looks like this. And there's two ways to do this. Number one, we can do it algebraically. But number two, which is going to be quicker, is to understand what the graphs look like. So by the end of chapter one, you should be able to recognize what this graph is going to be if you graph it. If you look at this, you should be able to know what that's going to be look like, and then you should know what this is going to look like. So first, I'm going to do talk about the actual graph. So in section 1.1, if the highest variable for x is 1, then in the last two sections, we learned that this is going to be a line if you graph it. So the line is going to either go up like this, or it could go the opposite direction. Whether it's like this one or this one, if you were to draw a vertical line test, it's going to pass that vertical line test. So here all lines are going to be, anything that's a linear equation would be a function. They'll pass the vertical line test. Letter B, the graph for this is going to be a parabola, so it's going to have the following shape. And you'll learn that in the next few sections coming up. So if the highest power is 2 for x, it's always going to look like a U shape that is opening up, or it could open down as well. So regardless if it opens up or down, then you can see that it's going to pass that vertical line test. So we say that's going to be a function. And then the last one you saw in the last section, if your x is squared and your y is squared, then this is going to be a circle. And since it's a circle, then it's going to fail that vertical line test. So we say that this is not a function. Now, algebraically, what you want to do is first you want to solve for y. So I'm going to subtract x on both sides and divide by 4. So y is equal to negative 1/4 x plus 2. So then what you want to do with this result is ask yourself, for whatever value I put for x, is it going to give me one output? So for example, if I enter a negative 4, this would become 1 plus 2 is 3. So if I enter negative 4, I'm going to get just an answer of 3. If I enter a 0, then my answer is going to be 2, because this would be 0 plus 2. And if I enter, let's say, a positive 4, negative 1/4 times 4 is negative 1, plus 2 will give me a 1. So you can see that these values here are going just to one item. So this is going to be a function. Same with letter B. What you want to do is solve for y. So I'm going to add 4x on both sides. And again, if you enter, let's say, a negative 1, negative 1 is going to be a positive 1, plus 4 plus 36 would be 40. If I enter 0, then I get 36. If I enter 1, then I get 40 again. So notice negative 1 goes to just one thing, 0 goes to one thing, 1 goes to one thing. So this is going to be a function. And then the last one, I want to solve for y, so I'm going to subtract x squared on both sides. And to solve for y, I need to take the square root. So y is plus or minus negative x squared plus 4. And so if you notice here, if I use 0, then 0 is going to give me 0 here, plus 4 is 4. The square root of 4 is going to be 2 or negative 2, since we have the plus or minus. So you can see that 0 is giving me two answers, 2 and negative. Therefore, this is not a function. So basically, if you have to take the square root to simplify the function, then it's going to be not a function automatically. So anytime that you have to take the square root, then it's not going to be a function. So let's look at another example. let me write it, I'll write it here. Let's say we have letter D. So y is equal to the square root of x plus 4. So notice here that they already tell you that y is equal to this. So you personally don't have to take the square root as I did in letter C. And so here, for whatever x you put in here, if x is 0, then you get 0 plus 4 is 4, and the square root of 4 is 2. So 0 is only going to go to one number, 2. And if you put a negative 1, you'll get the square root of 3. And if you put a 1, you get the square root of 5. So they'll be going to just one item. So this would be a function. So the point is, again, if you have to take the square root, then it's not going to be a function. If the square root is already there without the plus or minus sign, then this is going to be a function. Okay, the next part of this section is to evaluate what we call the functions. So the special notation f of x is read as f of x or f at x. Y is a function of x, represents the value of the function at the number x. So basically, f of x is like a nickname that is given to y. So for example, my sister's name is Crystal, but I can call her Chris, or I can say Mija or whatever. And doesn't matter what I call her, whether I use her name or something else, she's just still going to be Crystal. So in math, we are used to working with, let's say, y, the dependent variable. Or instead of y, we can say, call it f of x. Okay. And so that's still going to be the same thing. So for example, if you have f of x is equal to 3x plus 4, then this equation, y equals 3x plus 4, is actually the same thing. F of x is just y. The only reason is the notation. The second one, y equals 3x plus 4, this is just an equation. But here we're saying that it's the function that we're looking at. So it's the same thing, it's just a nickname for y. So how do we work this out? So what we want to do is we want to evaluate the function. So what you want to consider here is that the number in the parentheses is representing your x that's taking place of x. And so if we want to evaluate f of x is equal to x plus 5, then anywhere that you see this x, you're going to replace it with the number in the parentheses, in this case 3. So we have 3 for x and then plus 5. So here's x. Instead of x, I wrote 3. So now if I simplify, f of 3 is equal to 8. All this is saying is that whenever x is 3, you're getting the 8. So here x is 3 and your result was 8. Okay, so your answer is this right here. So we find f of 0, same idea. In this case, what we're replacing for x is a 0. So anywhere you see an x, we're replacing it with 0. So f of 0, 0 plus 5 is 5. So my answer is 5. Same thing here. I'm replacing x with a negative 1. So f of negative 1 would be negative 1 plus 5, which is 4. And last, we have f of x equals x plus 5. So x is going to be replaced with whatever's in the parentheses, in this case, a. And there's nothing I can do with a plus 5, so that just stays as a plus 5. They're not common terms. So let's try example 8. So anywhere you see an x, we're going to replace it with the number 2. So here I have an x, so I'm going to replace it with 2. And here I have an x, I'm going to replace it with 2. So I get 10 minus 3 times 2 squared is 4. Negative 3 times 4 is negative 12. 10 minus 12 is negative 2. So my answer is negative 2. I would like for you to try letter B. If you do this correctly, your answer is going to be negative 38. Please reach out to me if you don't get this answer so that I can work it out for you. The next one, letter C. So now x is going to be replaced by whatever's in the parentheses, which is this whole thing. So my equation is f of x equals 10 minus 3x squared. So anywhere that I see an x, I'm going to replace it with x minus 1. So here's an x. And then we want to simplify. So x minus 1 squared is the same as x minus 1 times x minus 1. So we're going to multiply these out. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative 1. Negative 1 times negative 1 is positive 1. And then let's distribute this 3. So we have negative 3x squared plus 3x plus 3x minus 3. Gather your like terms. So we have negative 3x squared plus 6x, 10 minus 3 is 7. So my answer is negative 3x squared plus 6x plus 7. Okay, the next one, we have f of x is 2x squared minus 4. Here we're substituting negative 1 for x. Negative 1 squared is 1 times 2 is 2. 2 minus 4 is going to be negative 2. And then the next one is f of x is equal to 2x squared minus 4. So I'm going to replace my x with x. So and instead of x, I'm going to replace it with x, which is the same thing. So my answer is just going to be the same equation. So f of x is just itself. And then last, 0. So I'm going to replace x with 0. 0 squared times 2 is 0. So we end up with negative 4. Okay, so the next one, page 20, we have let h of t be the height above the ground and feet of a rocket t after launching. Explain the meaning. Okay. So h of t, remember this is like your y, and that's going to be the height above the ground after t seconds. So t is going to be like your x, but instead of y and x, we're just calling it by t. So what this means is that this number in here represents your t, and t is time. And the answer is going to be your h of t, which is your y, and that is your height. Okay. So in other words, another way you can see this is that this is your input, and then this is your output. Okay. So t is time, h of t is height. So we can write a sentence. So what this means is after 1, since it's time, they tell us time is in seconds. So after 1 second, the rocket reaches 200 and the height is in feet above ground. Okay. And then the same for h of 2. After 2 seconds, the rocket reaches 350 feet above ground. Okay, so again, the number inside represents t. The actual answer is h of t.